Today we're going to check out Quinly from 3DQ, a fully automated continuous 3D printing system. Hello everyone, Chris here, and today is going to be a very interesting build. And there's a story with this one. A few weeks ago I was talking with Aaron over at Metaform, more on Metaform on the channel in future videos, but he had said he has a system from 3DQ that allows him to continuously print via a Raspberry Pi on his Ender 3, and it even ejects the model and starts the next one. And of course I heard this and had to check this out. So he got me in contact with 3DQ and they sent over a DIY Quinly setup. And that's what we're going to do today. We're going to walk through the whole setup, what it is, how it works, and hopefully get continuous printing off our Ender 3. So let's start by just taking a look at their site and letting me show you how this might work out. And this picture kind of says it all. Basically, they've tilted the printer up. They have this very unique vapor print surface that allows the print to detach, and then they use the print head to sweep it off the front, so you can put it in a box or something like that. Now, this setup shows the 3030 extrusions that it's propped up on, but they also have a printed part that you can use for your stand, and we're going to try both setups just to see which one works the best. So there's quite a few pieces to get this set up and running. Now you're going to have to be able to flash your printer's firmware. Not all boards have a bootloader, but we'll talk about that in a little bit. They do use a custom firmware set. You're going to have a Raspberry Pi 4. They do recommend using the version 4 because of its more capable processor. That's going to run your Quinly software. There's an image for that. But the most important part is the build surface, and they provide this surface they call vapor. This is supposed to be able to hold on to any part when the bed is heated and then completely release it when it cools down. And this is a pretty unique surface, and the first thing you need to know is you don't want to clean this with anything besides soap and water. It will ruin it. And you definitely don't want to use anything like a scraper on it. But we will look at it further as we go on into the build. So now let's get started by taking a look at all the parts we're going to need for this and what is included in some of these kits. Now this is pretty much it. This is all you're going to get in the DIY version. This is $129 US. You get the vapor sheet that's going to fit on an Ender 3. You get a USB flash drive that has all your STLs so you can print your own parts. You get a little bit of hardware, some screws and T-nuts to attach everything. And you get a 16 gig flash drive for building your image that'll go on your Raspberry Pi. And that might seem a bit underwhelming to some folks, and I get that, but a lot of the power of this whole kit is going to be in this surface and the software that they give you to use. This does include the license to the Quinly software, as well as the firmware that you're going to have to flash to your Ender 3. There is a more complete kit available where you get all the printed parts and the tilt frame. Also, both of these kits come completely supported. You can contact them anytime. And of course, I did elect to print my own parts just because I wanted to see how this was going to go, so I could tell you how you could print yours. Now, a lot of these are very thin. Depending on how you print them, what material you use, you might want to consider an enclosure, especially if you're using PETG like I did, because some of these thinner parts are prone to cracking. You have a set of guides that guides the part into your box or receptacle. These go on the sides, these go around the front. You have a replacement spool holders piece and LCD screen, so you can relocate those to allow the part to eject a little bit better. And then you have an option of stands. You can use these just directly bolted on the printer, and then you could use a set of these with some 3030 extrusions. Again, I'm going to try both just to see how it works out. So there's all the printed parts. And the other big item here is the Raspberry Pi. There is some cost to this, I understand. This one cost around $90 US. This is the 8 gig model of the 4. Again, I've said it a couple times, they do recommend using the 4. And remember, you need proper power for your Raspberry Pi for it to work correctly. And in most of these kits, you're going to get some heat sinks, so we'll set that up. So that's a big thing to remember when you're going to use this setup. You are going to have a Pi. They do, again, provide the image that we can load. And if you need some suggestions on how to print your parts, after you purchase the kit, you will get access to all of the manuals and resources, and they give you some directions for each one that might help you print them. And it's important to mention that once you purchase the kit, they're going to give you a firmware file you have to flash to the printer. And they currently only support the stock Creality boards. This one has a 1.1.4 board, so the original one. But they are looking at supporting a lot of the other mini boards that are direct swap outs for the Ender 3 sometime soon. But we'll go over how to get that installed. So let's grab the firmware and let's get it on the printer. And after you have access to the site, they're going to give you a list of Creality boards that they currently support. Again, I have the 114, so the old school Ender 3 board. So we're going to grab this one. And they also do directly support some auto leveling if you have it. I do not, but it looks like they have a BL Touch version and an inductive probe version. But we're just going to go with the basic one for the default printer that uses end stops. So we'll download this guy. And when the download's complete and you've extracted all, you have the firmware in here. You also have a program that helps you burn a bootloader. I'll show you more about that here in a moment if you need one. It has a version of Pronterface on it and an Arduino IDE. A lot of you are already going to have this installed. But there's a few tools in here to get you going. But we're mostly interested in the firmware folder. And it has Marlin. So let's just bring this into VS Code. So now that it's all unpacked, we'll just go to VS Code, add folder, back to our download, and we'll just add in this whole firmware folder and hit add. Remember, I've said it a million times, but you need to add the folder that contains the Marlin folder. And if you need to know how to get VS Code set up, I'll leave a link in the description to a video that shows you exactly how to do that. But you're going to have Platform I/O. And once your VS Code and PIO folders have been built, you can just go over to the Platform I/O icon, find the board you're looking for. For the old school Creality boards like the 114, it's going to be a Sanguino 1284p. You can expand that one and hit build. Once the build is successful, let's go ahead and cable up USB. We'll just plug in right here and we'll power up. And now we're going to hit upload. If you have a bootloader on your board, the upload will be successful. So let's go ahead and hit it. And if you see this where it goes through multiple attempts but can't handshake with the board, then you're going to need to add a bootloader. I have several videos on flashing a bootloader to one of these boards, but let's just run through it real quick. Now once the cover's off, you're interested in the SPI pins right here. There's 6 pins, but they're really close to this LCD cable. So you're going to have a hard time getting your programmer in there. You only need to do this once, so what I like to do is to just pull the LCD cable and then pull this plastic clip that holds the cable in. You can just get your pliers in there and wiggle it out. Just be careful. It's no big deal. Remember which way it went in. The opening is going to go towards the back of the printer. It shows you on the board as well if you get confused. But now you have access to all these pins. And you're mainly interested in this pin up here in the corner. So if you're looking at the front of the printer, that is the top left row. That's the reset pin. And you want to make sure you line that up correctly on your programmer. I recommend you use something like a USB ASP programmer. These seem to work the best. And these pins, they usually give you one of these connectors that you can easily put on this board. You could also use some jumpers and jump over to those pins from another kind of plug if you needed to. Not that big a deal. But these programmers just plug in directly to a USB port, and they seem to work the best with the IDE and these boards. On this end of the plug, you'll see one of these is labeled reset. The bump on the plug does go towards the back of the machine. It actually won't fit very well the other way. But with that reset pin to the left, it just goes on here just like this. And the programmer side, we can go ahead and plug it in to a USB port on our computer. You're probably going to see the blue light on the board light up, and then you will have a light on your programmer as well. And with this firmware package, they have given us some firmware and a portable IDE that we can use to burn the bootloader. So the first thing we're going to do is introduce a driver for our programmer. That's what this burn bootloader package does right here. It has found our USB ASP since it's plugged in. We don't have a driver for it. We're going to use the Win USB driver. Let's just hit install. It's going to start the installation process, get some drivers on there. This does take a moment. And the driver was installed successfully. We can go ahead and close this and close this programmer. Then they've given us this batch file that we can run in Windows. This does a few things for us, but it also opens the portable version of the IDE so we can burn the bootloader. You can double click this file. Windows might complain about it, but you can go ahead and tell it to allow it to run it. And then you should be able to go up to Tools. Make sure you've selected the right programmer. Again, we have this USB ASP. And then just hit Burn Bootloader. It should happen very quickly. As long as all these messages are blue, there's nothing red down here, you have burned the bootloader. So we can close the IDE now. Go back to VS Code. We'll unplug our programmer from the computer and from the board. And we can put our LCD cable back on. And before we close up shop, let's go ahead and put our USB cable back on and verify we can go ahead and upload. And then we can hit upload. Now we're getting the reading and writing messages. Our bootloader was successful and we're getting ready to flash the firmware. When the flash is complete, you're going to come up to Marlin. You might have an EEPROM error. You just need to reload the default settings because you know your current EEPROM is going to be different from the one that they built. Just go into configuration and hit restore defaults. And then you can go ahead and hit store settings too if you like. That's the same as M502 and M500. And once that's done, you can see we're on 3DQ 203. So upgrading the firmware on the printer is now complete, but I want you to keep this in mind if you're going to get one of these kits. Some of these boards don't have bootloaders, so you're going to need some sort of programmer, or you can use an Arduino Uno to flash the board bootloader. Then you're going to be able to upload your firmware. So if you're not comfortable with things like firmware and bootloaders, this might not be for you, but you're going to have a few things ahead of time to make this happen. Now let's move on to setting up the Raspberry Pi and the image they give you for that. So when you purchase the kit, you are going to get an email. You have to sign up to be in this client area to be able to download their firmware. But there is a compressed version. I recommend you download the zip file. It's going to download a lot faster. It is 2 gig. And you're going to need a WPA supplicant file. This is where your Wi-Fi information is going to be stored. So go ahead and download that. While that's downloading, you should get a 16 gig card with your kit. If you're using one from something else, I don't know why you would be, but I recommend that you format it. So right-click, Format, and just use a FAT file system. Quick format is good enough. Once your image download is complete and you've unzipped it, if that's the version you use, they want you to use the Raspberry Pi Imager tool. It is free for download. You can use that for any of your Raspberry Pi images. It's right here. And if your SD card is mounted, you've got your image file. You can hit Choose OS. Then just scroll down and we'll just hit Custom. And we'll find our file. Here's our Quinly 019 image. Hit Open. We'll choose our storage. There's our SD card. And we'll hit Write. Remember, this is going to destroy everything on the card and write this image. And we'll hit Yes to continue. Once it's complete, we can go ahead and hit Continue. We can close down our imager. Now, I said before, you need that WPA supplicant file. That's to help you access your Wi-Fi network. You can download that from their Google Drive, the same place you got the image. And we're just going to open it up in Notepad++. And we're going to update our country code. Mine is US. And then you need your Wi-Fi network name. Remember, these are case sensitive. And you need your Wi-Fi password. This is also case sensitive. Once you have the file fixed up, you can copy it, and we'll open up our image on our SD card. Look for the one that says boot, and paste it right in here. The boot portion is the one that's mounted so you can access it from Windows. You might have to remount your card because the imager usually exits it, so you can unplug it and start using it. But now that you have your WPA supplicant file in there, we can eject the card and mount it on a Raspberry Pi. I got my Pi 4 ready to go. I put the heat sinks on just in case. We'll mount our SD card. We're going to go ahead and plug the printer in USB because the printer will report the IP address. Then we'll plug in our power and we'll go ahead and power up the Pi and the printer. You can also do this with an Ethernet cable if you like. You don't have to do it Wi-Fi, so you wouldn't need that file, but I think the Wi-Fi is very handy. And once Quinly comes up, It restarts the Marlin and it displays your IP. So I've got 1.80 on mine. Remember, you need to use port 8080 to be able to access this. So let's go to a browser, we'll open up a new one, 192.168.1.80, port 8080. And if you punch in the right IP, you go to Quinly. And we're idle, and it's ready to start accepting jobs. So the firmware is in place, we're good there. We've got a Raspberry Pi set up with Quinly, it's ready to start accepting jobs. Now we need to move to the hardware piece and actually get our printer ready to start printing in that angled fashion. So let's tackle that. So the first thing for the hardware is we're going to install our Vapor build sheet. And there's some very specific rules when doing this. In the kit, they give you some alcohol swabs, clean off the whole sheet really well. I suggest you just use them both at the same time. You want to make sure there's no oil on this bed. It'd probably be a good idea to go ahead and wash your hands while you're doing this cleaning process, just to not introduce any more oil than you have to. Once that is done, we are going to power up the printer and heat the bed to 40°C. Once you're up to temp, just give it a quick test fit here. Make sure it's sized correctly. And then we're going to peel about an inch, a couple of centimeters, off of one edge. And I'm just going to start in the back and line up that back edge. This is a pretty rigid material. I'll stick down that leading edge, just make sure everything's still lined up. And then we can go ahead and start pressing it down and take a lint-free cloth and just kind of work it onto that bare aluminum bed. And then we can just peel back the paper gradually, just working it on a little bit at a time. It's pretty obvious where it's stuck and where it isn't. And the adhesive on this thing is no joke. And the plate is on. Now before we start using it, we will clean it off again with a microfiber cloth, just a little bit of water and a little bit of soap, and that should be all that we ever have to clean it with. No alcohol, no acetone, nothing like that. You will damage it. Once the bed plate is on, we can go ahead and turn it off, let it cool down. Then we can start assembling some of the other hardware pieces. First thing we're going to do is remove our LCD holder. It's just these two screws here in the front. And we're first going to try our 3D printed legs. So the part labeled E19 is going to be for the left side. We're just going to use some M5 screws that came with the kit and the T-nuts. And then on the opposite side of the printer, I've got it up on its edge, opposite from the LCD. You probably don't have to remove the rubber feet if you want to. If you want to take this off at some point, you can. But we're going to use some M5 by 8mm screws and T-nuts that came with the kit. But our M19 part is for the left side. You're just going to put it in the bottom extrusion and swing it up. And then you can slide the T-nuts into this channel and just get your bracket as far forward as you can. And then secure it with those T-nuts. So make sure they spin all the way around. And we'll do the back one. And we'll flip it over and we're going to do the same thing on the side with the LCD. This is the E20 part. And that is a tilty printer if I have ever seen one. So now we have a set of skirts that help guide the parts off the bed. You have the part that's labeled E4. It's actually sandwiched underneath this front screw right here. So we'll just back it out a bit. And we'll slide our part on. You'll start this side into the bottom rung of the center extrusion. Just kind of wedge it down and then fold it down over that screw. It's probably easier for me to show you this on its side. This part right here actually clips inside that bottom extrusion channel, the one that you're not using. And this one just sets underneath that screw head. And you don't need to tighten it down too much, just so it doesn't move anywhere. Then we'll go to the other side and deal with our LCD screen. And since the LCD might get in the way of the parts ejecting, we're going to move it over here to the side. They provide STLs for these parts. Your E9 part is your mount. It uses those same two holes that the stock LCD does. You have another part that needs to go in there, but there's also tabs that go into the extrusion. So you can kind of slide it in from the front. we'll go ahead and put this screw in just to hold it. But for the other one, just like on the other side, you're going to want your E5 tab. Again, it goes in this bottom extrusion. And then get sandwiched underneath that other screw. And my stock screw wasn't actually quite long enough to get this done, so I am going to sub in an M5 by 12 millimeter screw. Just keep that in mind. And then your stock LCD is actually going to go over here. They give you some large M5 square nuts. They'll go down in the top of this printed part. And then from the back, you can use some of the M5 by 8s. They just go through the back of this carriage and then screw them down to this printed part. Then you can go ahead and plug it back in. It's the EXP3. Remember, it's the one closest to the printer side. Then we can go ahead and finish up our shield pieces. We have our E3 piece. It's going to fit in right in here, just to kind of fill this gap so you don't lose any parts in there. And then we have two guards for the sides. They go in these top extrusions here. One here. This is the E7 piece. They just snap in. On the other side is your E6. And on this side over here, there is a little spot, a gap, so you can mind your Z end-stop wire. And for our last printed part install, we're going to use this E8 part and move the stock Ender 3 spool holder over here to the side, which is always a good idea. It's not really good on the top. But they give you some M5 by 25s. Those just go through the part here. T-nuts on the back, and then it mounts right in here. Remember, we want to line it up with that extruder input up here. And once it's attached onto the extrusion, you have two more of these large square nuts we can put in our part. A couple more M3 by 8 millimeter screws. You can use the stock ones as well. And then you can just put your spool holder barrel back on. And in that orientation, that should allow the spool to set flush. I'm not exactly sure how that's going to work feeding it in, but we'll try a few different positions. There are some alternate spool holders out there you can download as well. So the install is complete. Now we'll have to do a little bit of learning as far as the software goes, how to set it up, but that shouldn't be a big deal. The real key to this is how this build plate is going to work. What type of filaments will release successfully? How well do they grip? And that's what we're going to have to test. We're going to have to run through a couple of different types, because if you want to use a setup like this, continuous printing, you want to make sure that the filament you use is going to work successfully. So I'm going to clean the build plate. Remember, we just want to use a little bit of soap and water, some mild detergent, nothing else. And then we need to level the bed, just like you would on your regular Ender 3. And we're going to test out some filaments, just to see what can complete, what can successfully offload the bed, so that this whole mechanism just works. So yes, we always need to level every printer, but this one, you need to be really careful, because if you contact the nozzle to that surface, you're pretty much done. So we're going to try to go slow and be as accurate in this process as we possibly can. So make sure there's absolutely no heat on the nozzle, and it is completely clean. You don't want any extra filament. In fact, don't even load the filament until you're done with this process. You might, depending on how your level is, what springs you're using, this one actually has silicone holders instead of springs. Depending on where your bed is setting, you might need to adjust your end stop up or down to make this surface work. It is probably just a bit thicker than stock. So we're going to heat the bed up to 60°C. Remember, leave the nozzle cool. And then we're just going to use the screen to move the nozzle to the front corner over here. I'm going to do it close to that screw where we level. Because we want to move intently, that's why we're using the control knob instead of just doing it manually. But we're just going to do the same old paper move here. We're going to move Z down really slowly until it touches this paper. So I'm all the way at 0 in Z, and I'm not quite touching the nozzle to the paper yet. There's no drag. So you can either adjust your end stop or try to adjust your bed wheels. I think I have enough room for the bed wheels, so I'm just going to start there. Back this one off a bit. We have just a little bit of drag, so we're good here. I'm going to move over to the front right. We have a little bit of drag there, so I'm going to move to the back. I advise you to keep your paper underneath the nozzle the whole time you're moving around, Just in case there's a large inconsistency you don't want to hit, just make sure the paper is still free the whole time you're moving. Make slow movements. Should be good on that one. And then finally, to the back left corner. And we should be good there. And I suggest you go around and do this process on all the corners a couple of times, just to make sure you're consistent all over the whole bed, because you don't want to gouge it. But when you are confident, then you should be able to auto home. You might still want to keep your paper underneath here, even during this process, because it's going to go to the center of the bed to home. And it did come down and grip it just a bit, so we should be good. Now that your bed is level, and we're sure that we're not going to damage the bed, your install of Quinly should come with a mock print G-code, just to test to make sure everything's working correctly. Don't load your filament or anything yet, just run this job. So over here in the Jobs tab, here's your file name. You can select it and hit Send to Queue. If you'd like to do multiples, you can adjust it here. Let's just do 2, just for fun. And our mock print is taken off. It's just going around the entire bed. This is also a good indication you're not colliding with anything. And when the print completes, now we go into a mode where we're waiting for the bed to get down to 26C. And that's somewhat concerning because when we try ASA, that might take a really long time. You can go into the print console and see a few things inside the software. There's not a whole lot to it, but it does at least tell you if it's printing, which number it's on, or if it's resetting. When we get down to temp, then the printer starts a sweeping process. This is going to clear anything that's on the bed and knock it off the front. And after it's swept the whole bed, then it's going to go back and start the print process all over again. So the setup went pretty well. It is working as expected with that mock G-code, but there's 2 things that concern me right now. One, the time that it takes to cool the bed down and how far it has to get down to be able to remove that part. Like I said before, imagine if you had ASA or ABS. That could take a long time and add to your print time trying to replicate parts. In this test, just to speed it up, I actually clamped this fan on top so it would cool it down a lot quicker. Not the most elegant of solutions, but this whole thing is just begging for some sort of automatic fan plugin. The second thing is the software. It is in beta, it's very new, but a lot of the features are clunky. It doesn't have a whole lot in there, and even something as simple as deleting a print and starting a new one just doesn't seem to work. I had to reboot the Pi a couple of times. But I think if you get everything set up just right, it will work, but there's a lot of room for improvement there. But now we're going to move on to some filament tests. And of course, we'll start with trusty PLA. So for our tests, we're going to need a file to print. Now, I just want to print a simple box, but I ran into some issues. So I tried Prusa Slicer for the testing, but it doesn't actually support Prusa Slicer yet. I guess there's a few bugs that the firmware that this setup uses doesn't like. So they prefer Cura. As you know, on this channel, I don't use Cura a lot. I'm not really familiar with a lot of its features. But even though I'm in Prusa Slicer, I still wanted to go ahead and create my shape because Cura doesn't do that I know of. So I'm just going to create a shape real quick. And we're just going to do a 25mm box. And I'm just going to export it as an STL. Then I can use it inside Cura. So bringing it into Cura, there are a few settings you need to pay attention to if you're using this setup. One thing that is a concern when you're doing print after print in this automatic fashion is how you do your skirt or even a brim. Because the skirt is going to have to come off with the part so the build plate is clean. And I have had some issues with that during this testing, but there are a few settings to tweak to help you out. So for this print, we're just going to do this box, no top layers, a couple of bottom layers, and 2 walls. So it's a quick print. Again, this is just testing out the filament to see how well it sticks on the plate. But then in skirt, 3DQ recommends that you use 1 line and you make it a distance of 0.39 away from the printed part. That's when using a 0.4 nozzle. That way, it's pretty much just stuck to the part and it'll come off all in one piece, you might have to clean it up just a little bit after it gets removed. So that's how they're tackling this skirt issue, so you can have the build plate clean every time it removes a part. And if we slice that, again, it's just a really simple box, but this is going to be our test object. I'm going to slice this in a bunch of different styles of filament, and then we'll take it to the time lapse. So I've got all the different test filaments loaded up here. To start one, it's pretty self-explanatory. Grab the first one, punch in the number that you would like, and hit send to queue. And here's all our test prints. Now let's just get polycarbonate out of the way first. I tried it twice, wasn't surprised that it wouldn't stick to that build plate. Polycarbonate is just really hard to print, plus I don't like to run these PTFE line Hotends past 250. Sometimes I print polycarbonate around 275. So it's a no-go, not shocked. Then we have nylon. Now this is Tallman 610. I don't even think they make that anymore, but I've had a spool locked away in my dry vault for a long time, and I wanted to give that a try. Now, I got a first layer down, but after that, it was also a no-go. Not shocked. Usually you have to put some glue stick to get nylon to stick down. There are different types of nylon nowadays, though, like bridge, that you might be able to get to stick to this plate, but the nylon I had, also not going to happen. Then we moved to PLA. It worked just fine. I had it just a little bit too close to the build plate. So each material you go through and you test, you're going to have to adjust your bed level, just like any other printer, and you're going to have to get used to this build surface. It is just a little bit different. But PLA is okay. PETG, it did fine as well, no problem. It probably did the best at getting removed from the plate. ABS, it did hang in there, but it was starting to curl pretty bad. Pretty typical for ABS. Of course, it delaminated because it was in the open air. So it was successful, but I wouldn't trust it on a long print. It was probably just barely on that plate. TPE, this is a very cheap TPE that I had. This is Inland brand. It did stick really well, probably too well. It had a problem getting primed to lay down that first layer. And again, that brim or skirt that I talked about during the Cura setup, that's going to be key getting these dialed in for different types of filament to this build surface. It's going to take some getting used to. But if you want to use TPE, you can probably get it done. You're just going to have to tune it in. Notice during the time lapse though, when it tried to remove it, that it actually hit it twice and stuck on the hot end. That would probably be better if you had a different type of part rather than this flimsy part, but it's going to take some tuning. And then ASA. The ASA did fare a lot better than the ABS. Remember, ASA is kind of an ABS replacement, but you can see how the edges started to curl. It was probably also just barely hanging in there. And while we're talking about bed adhesion, let's talk about cleaning this build plate one more time. Remember, it's very important not to use any type of solvent or cleaner to clean this bed, just soap and water. Even with the soap, you don't want to use just any kind of soap. They recommend using this 7th gen soap. It doesn't have any alcohol in it. Things like Dawn do. So you want to be very specific at what type of soap you use on these. Natural soap seems to be the best. But if you do need to clean it, I've found just putting a dot of soap on the center, and then I just spray the soap with my water bottle and just wipe it until the soap is gone. That really does help it to stick and get it all cleaned up if you're having issues. So just keep that in mind. You don't want to use just anything to clean this off. So there's all the test prints, and the takeaway here is that not every filament is going to work with this vapor print surface. There are some that work pretty well, like PETG and PLA, which are some pretty common filaments that I use all the time. And it does take some dialing in to get used to this surface, just like a lot of other print surfaces. Also, I think you could probably use another surface, like a PEI sheet. If you had it tuned in really well, you could probably achieve the same results. As always, your mileage may vary. Now I want to set up a test print, maybe something a little more practical that I can run multiples of, and then we can just see how it works end to end to make sure it's going to release and start the next one correctly. So let's kick one off. And here are our test prints. I did 10 in total. I decided to go with PETG, this is Filament, and they all came out pretty well. It's got a nice texture on the back, it's real shiny. Most of them stuck. I did have a problem with one. This one right here, for some reason, I had a layer shift. And it was the first couple of layers. It did complete, but I really couldn't catch it even on the time lapse to figure out what happened. Everything else just came out. No problems at all. Now I did try ASA, but it didn't go so well. I got about this far into the print, it started to curl, it is ASA, and it came off the plate. And I found this lovely surprise. The rest of the coaster was attached to my Hotends sock. Good thing I had a sock on it. But I was able to recover from this pretty easily. So to get ASA to work, you might even have to have an enclosure. You're going to have to do a lot of dialing in on that print surface. I just couldn't make it happen. And through all my testing, these 3D printed feet to tilt it up actually work great. In fact, I think if I use the aluminum pieces, it might be just a little bit too tall for my shelf, but I still wanted to try them out, just in case that's the route you wanted to go. I just got a couple of 30-30 extrusions. I made them the same length as the Ender 3 feet. They are 300 millimeter. And you can use these brackets to attach them to the side of the printer. These are E17 and E18. So these feet actually fit on similar to the 3D printed ones. They have a little lip that goes down in the extrusion. For this side, you want E17. This is the left side. The fatter part goes towards the back of the printer, and the larger ear goes towards the 30-30. You have a shorter one that goes onto the printer. So it fits just like this. You can use those same M5s and T-nuts as we did on the 3D printed feet. It goes as far forward as you can go. Again, I don't think you need to remove that rubber pad. You can make it work. So they're on, again, the same hardware to attach them to the printer as the printed feet. You will have to remove your LCD, so make this decision before you get everything put together. And then on the extrusion side, they do give you some M5 oversized T-nuts to use on those 30-30s. and they'll just go on just like this on both sides. So we've got both of them on, the screen reattached, and I would say it is just a little bit more rigid install. Again, those 3D printed feet did work pretty well, but this might be an option for you if you don't have a really large build volume on your printer. These are fair sized parts and might be kind of tricky to print. The brackets for the extrusion are much smaller and an easier print. So that's up to you. So there it is, the 3DQ Quinly continuous 3D printing system. And I do see some use cases for this setup. I think if you're using PLA or PETG, you could get set up really quickly and start reproducing parts. Imagine if you had 5 Ender 3s with this setup. You could really turn out a lot of parts quickly. And if you had just the same part over and over, this would work great, or even just a handful of parts. Now, the vapor build surface, it does take a little bit of getting used to, and it's not going to work for every size part or every filament, so you definitely want to be aware of that. And the software that comes with this setup needs some work. It is still in beta, but there's a lot of little things that don't work quite right, and it would be really handy to have a few more plugins or just added features to help us with even cooling down the bed, like I mentioned before. So I'm excited to see what 3DQ is going to do with this development going forward. Now, no money has exchanged hands between 3DQ and I, and all opinions expressed are my own. That is it for today. Hopefully you liked this video, and I'll see you really soon on the next one.